Hey there, curious minds. Have you ever thought that maybe time isn't the same for everyone? Or wondered if light really always travels at the same speed? Well, guess what? You're about to dive into some of the wildest, most mind-bending ideas in science, all thanks to a guy who loved messy hair and thinking outside the box, Albert Einstein. Now, before Einstein came along, things were nice and simple. Speed, time, space, everything was pretty straightforward. But Einstein, being the genius he was, decided to flip everything upside down, and trust me, the world hasn't been the same since. So, buckle up. It's time to learn about the theory of special relativity. What is it, you ask? Stick around, and let's find out. Here's a fun one for you. What if I told you that time isn't the same for everyone? That's right, your watch could be ticking at a completely different pace compared to someone else's, and it all depends on how fast you're moving. Imagine this, you're sitting on a train going super fast. I'm talking like, almost 90% of the speed of light fast. Now, you probably think time is ticking away like normal inside the train, right? But wait, here's where it gets weird. To someone standing on the platform, watching you zoom by, your clock would be running slower. Yep, you'd be aging slower than them. That's called time dilation. The faster you go, the slower time moves for you. Sounds like a superhero power, right? But it's real, and scientists have actually tested it with super accurate atomic clocks. These clocks on fast-moving jets tick slower than those on the ground. So, yeah, this isn't a sci-fi plotline. This is real-life science. Alright, let's talk about light for a sec. We all know light is fast, right? But what if I told you that no matter how fast you're moving, towards the light or away from it, the speed of light always stays the same? Doesn't matter if you're zooming towards it or running away like your life depends on it. The speed of light stays constant at 186,282 miles per second. That's like the ultimate roadrunner of the universe. This was mind-blowing back in Einstein's day because, before that, everyone thought light would behave like sound waves. You know, if you're moving toward a sound, it sounds higher pitched, and if you're running away, it sounds lower. But light doesn't follow that rule. It's just, well, light, and it doesn't care what you're doing. It'll travel at the same speed no matter what. Okay, time for the big one. You've seen it everywhere, E equals mc squared. You've probably even seen it on t-shirts, mugs, and memes. But, what does it actually mean? It's simple, E stands for energy, m is mass, and c is the speed of light. So, here's the crazy part, mass and energy are like two sides of the same coin. You can transform mass into energy, and vice versa. So that tiny little bit of mass can turn into a huge amount of energy. That's right, folks, tiny bits of matter can release crazy amounts of energy. Think about it, the sun is basically a massive nuclear furnace, turning tiny bits of mass into enough energy to light up our entire solar system. Talk about a seriously powerful recipe, but here's the thing, Einstein's theory of relativity isn't just something you read about in textbooks. It's actually pretty important in real life. Have you ever used GPS? You know, that magical thing that gets you from point A to point B? Well, guess what? It relies on relativity. See, GPS satellites are zipping around Earth at high speeds, and their clocks tick a little differently than ours on the ground. If scientists didn't account for these tiny changes in time, your GPS would be way off. I'm talking several miles off. So every time you get to your destination, you can thank Einstein for keeping you on track. Now, for the grand finale. Ready for this? Einstein didn't just stop at time and light. Oh no, he took it even further. He showed that gravity is caused by space-time itself bending around massive objects. Sounds confusing? Let me break it down for you. Picture space as a giant rubber sheet. Now, drop a heavy ball in the center. What happens? The sheet bends around the ball. Well, that's pretty much how gravity works. Big things like Earth or the Sun bend the space-time around them, and objects like you and me just fall into that bend. That's what we experience as gravity. So, no, gravity's not some invisible force pulling us down, it's just space-time doing its thing. Pretty cool, right? So, what's the bottom line here? Einstein didn't just mess with our heads, he changed everything. From the GPS in your phone to understanding black holes and even the Big Bang, his theory of special relativity revolutionized the way we see the universe. And just think, the next time you're speeding down the highway, you're probably experiencing a tiny bit of time dilation yourself. It's not science fiction, it's the real deal. Time isn't what it seems, and space is way more mysterious than we ever imagined. Thanks for hanging out with us on this cosmic journey. If you had your mind blown, or even just had a few laughs, hit the like button, share with your friends, and of course, don't forget to subscribe for more awesome science content. Catch you next time, Space Explorers.